Hello and welcome to our lesson on radicals, dividing radicals with variables. First, a really quick review. The whole number is the big number on the outside. The radicand is anything that's underneath the radical sign, and that teeny tiny 2 right there is the index. When we divide radicals, we need to make sure that we don't actually divide them. It's a lie, kind of like the exponents do. Instead, you're going to end up multiplying because you can't have an irrational number on the bottom. So in order to get rid of it, you're going to have to multiply the entire fraction by the whole denominator. Treat the problem as a regular multiplication of radicals, and then simplify any whole numbers and any remaining radicands. Let's take a look and see how this works. We're not going to divide, we're going to multiply first, and we're going to multiply it by whatever is in the denominator. So that's 6x radical 22x. And if you multiply it to the denominator, you have to also multiply it to the numerator. Whatever you do to the bottom, you have to do the top, and vice versa. So the first step, when we do the multiplication, on the bottom, we end up with 36x squared, and then the radical sign, 484x squared. Because remember, when you multiply x's with variables, when you multiply variables with exponents on them, you don't actually multiply them, you add them. Now we're going to take our whole number times our whole number on the top. So we're looking at negative 12 times 6x. So you're going to get negative 72x. And then you're also going to multiply radicals. So it's 22 times 2, which is 44. And exponents don't get multiplied, they get added. So that's x cubed. Now, for step 2, we are going to go ahead and reduce where we can or simplify where we can. Turns out that these are not fully simplified, obviously, because we multiplied numbers to create them. So we're going to have to go ahead and simplify them out. We had negative 72x with a radical 44x cubed, and we had all of that over 36x squared, and then a big radical of 484x squared. 484, we created that by multiplying 22x times 22x, so that makes it a perfect square, which means when we simplify it, we just take it back down to 22x, because 22x times 22x is 484x squared. And we still have our 36x squared out there, so that needs to be multiplied. The 44 was created when we multiplied 2 and 22, which is 2 and 11. Now we have a pair of 2's and an 11 left over, so the 2's come out and the 11 stays in. We also had a negative 72x sitting out there. It has to be multiplied by the 2. And don't forget, we have an x cubed. How many groups of 2 are in 3? 1 group of x's, and 1 guy is left over. Let's go ahead and multiply that out. So we're going to take negative 72x times 2x, and we're going to get a negative number, and it's negative 144x squared, because when you multiply exponents, you really add them. And then you still have your radical 11x. And then on the bottom, you're going to end up with 792x cubed. Alright, so we said we had negative 144x squared, radical 11x, and on the bottom we found out we had the 792. Okay, let's fix that so you can see it. 792x cubed. We can reduce. Specifically, we can reduce the x's, and we can definitely reduce the numbers. So if we do that, it turns out that 144 and 792 are both divisible evenly by the number 72. So we're going to divide them both by 72. When we do that, we're going to get a negative number, and it's negative 2 over 11. And we still have our radical 11x, but those x's can be reduced. And when you are dividing, you're really subtracting. So we have 2 minus 3. That's a negative 1. And a negative x tells us that it needs to be switched on the location. It's not going to be negative up top, it's going to be a positive down below, so we end up with this. So our final answer is negative 2 over 11x, and then radical 11x. You would then go back and double check your work. There's no shortcut on your double check. All you can do is go back, recheck your multiplication, recheck your factor tree, and make sure that when you simplified, you did it correctly. Okay, so let's look at another problem. Now we're going to take this one, not dividing it, we're going to multiply by the denominator. So it's 5 radical 5x. And whatever you do to the bottom, you do to the top. Keep the fraction equivalent. When you're multiplying out fractions, you are simply multiplying across. So you're going to take 5 times 5 on the bottom, and you're going to get 25. Then you're going to take radical 5x times radical 5x, and you're going to get radical 25x squared. And then on the top, you're going to take 15 times 5. That's going to get you 75. And then 25 times 5 under the radical is 125. And x cubed times x is really adding the exponents, so it's x to the 4th. Now, if you notice something, you've got 25x squared square root. Isn't 25 a perfect square? Wouldn't that be 5? And isn't x squared square root of really back to x again? In other words, the reason why we're multiplying by this radical all over again is to actually get rid of the radical. We end up right back to the radicand itself minus the radical sign. So when we do that, it turns out that this on the bottom goes to 5x, which was our original denominator that was underneath the radical sign. But we still have that 25, which was the whole number squared. Now up top, 125 is not fully reduced because obviously we use numbers to create it. So 125 is going to be 25 times 5. Then we have 5 and 5, and they're all primes. Pair of 5s come out, lonely 5 stays in. So we have 75, which was our original whole number up there. We got to carry them over. Then we have the pair of 5s being multiplied. And then, don't forget about your variable and your exponent. How many groups of 2 go into 4? 2 groups. And is anyone left over? Not on the x's, but definitely that lonely little 5 from over here is still left over. Okay, now if you notice something before we start multiplying out, don't we have a set of 5s? They can cancel each other out. And if you have 25 here and 75 there, can't 25 go into both those numbers? So 25 is gone. And how many times does 25 go into 75? Or think about it this way. How many quarters are in 75 cents? 3. So this actually reduces to 3 on the top. Now you've got an x squared and an x. If you're dividing exponents, it's a lie. You subtract them. So 2 minus 1 is 1. And then you have radical 5. So this right here should be your final answer for that problem. 3x radical 5. Okay, so let's do our very last problem. Now we're going to multiply by the denominator for both the numerator and denominator. Remember, there's really no division of radicals. You're just multiplying them. You have 3m times 9y on the bottom and 3m times 9y on the top for the numerator. Now we're going to use the shortcut. Remember, if you multiply two exact radicals times themselves, they square themselves and then they square root themselves right back to what they were originally, but without the radical sign. So on the bottom, we're actually going to have 9y without the radical sign. However, the whole numbers do get squared. So 3 times 3 is 9, and m times m is actually m squared because you're adding exponents. And now you're going to take m cubed and you're going to multiply it by 3m. So you're going to have 3m to the 4th. And then you're going to take 9 times 6, which is 54, and it's under the radical still. And then m times y. They're not like terms, so you just keep them as m times y. First thing, 54 not fully reduced yet, so we have to go ahead and break it down. And obviously we created it by 9 times 6, which is 3 times 3, and 2 times 3. Pairs stay in, pairs go out, singles stay in, so the 3 goes out. So you're going to take the original 3m to the 4th, this guy right here, he was already there, so he stays up there. You're going to multiply him by our new group of 3, And then underneath the radical sign is going to be that lonely 2 times 3, which is 6, and that my, because there were no pairs of them to take out, so they stay. Now on the bottom we still have 9m squared times 9y. Before we multiply everything out and then reduce, we can just flat out reduce now before we multiply. So take a look. I've got 3 times 3, that's 9. So if I have a 9 on top and a 9 on bottom, I can get rid of one of the 9's. I have m to the 4th and m squared. Don't divide exponents, you subtract them. So 4 minus 2 is 2. So that means on the top, I have an m squared. And I reduced out those 3's with the 9 on the bottom, because 3 times 3 got me the 9 on the bottom. I still have my radical 6my, nothing to reduce them by, and the only thing I'm left with now on the bottom, this guy canceled out, and I'm just left with my 9y. There's nothing further to reduce or cancel out. Everything is simplified as far as it can go, so this would be my final answer. M squared radical 6my all over 9y. Quick review, you cannot truly divide radicals. It must be turned into a multiplication problem. To do that, you're going to multiply the entire fraction by the denominator. The denominator and the numerator both get multiplied by the original denominator. From then on, you treat it as a regular multiplication of radicals process, and be sure to simplify any whole numbers and any remaining radicands. And that's it for our lesson on radicals, dividing radicals with variables.